Hi everyone, I am Teacher Michelle and welcome to another episode of Unang Math. In this episode, I will be discussing this lesson about symbols and ratio of similar figures. Okay, we have here these two figures, specifically these similar figures. This triangle is the reduced or the smaller version of this triangle. And this triangle is the enlarged or the bigger version of this triangle. You have to remember that if figures are similar figures, then it means the corresponding angles are equal in measures. So in here, this angle corresponds to this angle, so it means they are equal in measures. This angle corresponds to this angle, so equal in measures. This angle corresponds to this angle, so they are equal in measures. The only difference is that the length of the corresponding sides. Okay, the length of this side is longer than the length of this side because this is the bigger version or the large or the enlarged version of this figure. Okay, this one or this side is the smaller version of this side. And this side of this triangle is the smaller version or the shorter version of this side. Okay, now, in naming similar figures, we are going to use this symbol. And if we will read this one, we have here triangle ABC is similar to triangle DEF. Okay, moving on, let's talk about the ratio of the length of the corresponding sides of these similar figures. So if we are talking about the ratio, we're talking about, or this refers to the ratio of the length of the corresponding sides. So we have here these similar figures, specifically triangle ABC and triangle DEF. So triangle DEF. And these two triangles are similar figures. Okay, now, if similar figures, corresponding angles are equal in measures. This one equal to this angle equal to this angle. Okay, let's find the ratio, specifically of the length of the corresponding sides. So, we have here a given that this side is 3, or let's say 3 centimeters. This side is 6 centimeters. If we're going to write the ratio, then we have here 3 is to 6. And if we will simplify, dividing both numbers by 3, so we have 1 is to 2. So the ratio of the length of the corresponding sides of these similar figures is 1 is to 2. We can conclude that this figure is times 2 this figure. Okay, let's give another example by answering this concept check question. Okay, in the following diagram, quadrilateral ABCD is similar. We have here the symbol, similar to quadrilateral EFGH. So this is our quadrilateral ABCD. According to this, similar to this quadrilateral EFGH. We will be answering the following questions here. But before we will answer, let's try first to understand this figure. Since these two quadrilaterals are similar figures, then, okay, at first, actually, we can think that these are not similar figures. But since it's given that these are similar figures, so let's find the corresponding points for point A. Point A corresponds to E, B corresponds to F, C is G, D is H. So in this figure, if we're going to flip and enlarge, then this would be the quadrilateral. Okay, now, let's answer the first question. What's the corresponding vertex to point A? So this is point A, corresponding vertex is point E. So we have point E. What about the corresponding side to side BC? So side BC. Point B corresponds to F. Point C corresponds to G. So we have FG. So the side corresponding to side BC is, okay, we have side FG. Okay, for the third question, the corresponding angle to angle H. Okay, where's angle H? This angle. And this angle corresponds to angle D. Okay, for number 4, we will be looking for the ratio of similarity between these two quadrilaterals. Okay, if we are going to consider this side, BC, so it corresponds to this side, FG. So we have here 1, 2, 3, 4, so 4 squares. How about here? 1, 2, 3, 4, 5, 6, 7, 8. So we have here 8 squares. So 4 is to 8. And if we will simplify that, it would be 1 is to 2. So the ratio of similarity between these two quadrilaterals is 1 is to 2. So this length, multiply it by 2, then that would be the length of this side. So in here, this length, just multiply it by 2, then that would be the length of, okay, take note, this is side AB. Side AB corresponds to EF, so this side. So just multiply it by 2, then this is now the measure. Okay, what about AD? So this side AD corresponds to EH. So this is times 2 this side. DC is HG. So this is times 2 this side. Okay, now let's answer the following simple questions. Let's start with this one. In the diagram, we have your triangle ABC is similar to triangle DEF. So ABC, this is similar to DEF. Okay, let's find the following. Okay, first, the ratio of similarity between triangle ABC and triangle DEF. Okay, we have given here in triangle ABC that this side is 4 centimeters, this one is 6 centimeters. What about here? This is given 9 centimeters, and then we have an angle here given 120 degrees. First question is the ratio of similarity between triangle ABC and DEF. So, since this side is given and this side is given, we will be using 6 centimeters and 9 centimeters. So, we have here 6 is to 9. And if we will simplify, 6 is to 9, divide both sides by 3, then we have here 2 is to 3. So the ratio of similarity between these two figures is 2 is to 3. Okay, for the second question, for the second statement here, what is the length of this segment DE? So where is segment DE? This side. Okay, this side corresponds to this side. So this is 4 centimeters. And let's say this is Y. Okay, since these two figures are similar figures, then the ratio also is 2 is to 3. So 4 is to Y, that would be equal to 2 is to 3. And to find this value or to find this length, that would be 2 times Y and 4 times 3 equals 4 times 3, so 12. So it means Y is 6. So this is 6 centimeters. So length of DE is 6 centimeters. Okay, for the last question or for the last number in this question is, what's the measure of angle B? So where's angle B? This angle. These two figures are similar figures. So it means if this is 120 degrees, This corresponds to this angle. So this is also 120 degrees. So the measure of angle B is also 120 degrees. Okay, what about this last question? In the diagram, we have quadrilateral ABCD. So ABCD is similar to quadrilateral EFGH. Let's find the following. Okay, first, the ratio of similarity between these two quadrilaterals. Okay, if we're going to check the given, in this quadrilateral, this side is given 6 centimeters, this side is 9 centimeters, and then this angle is 70 degrees. What about in this quadrilateral? Okay, this side is also given 12 centimeters, this angle is 100 degrees, and this angle is 85 degrees. In finding the ratio of similarity between these two figures, okay, we can consider this side because both are given. So this is 9 centimeters, 12 centimeters. So we have 9 is to 12. And if we will simplify dividing both numbers by 3, so we have 3 is to 4. So the ratio of similarity between these two quadrilaterals is 3 is to 4. Okay, now, the second question is the length of segment EF. So what would be the length of segment EF? Segment EF or side EF is this side. And this side corresponds to this side. It's given that this is 6 centimeters. Okay, let's say this side, or let's represent this side as Y. So we have here 6 is to Y, and that would be equal to this ratio, 3 is to 4. So to find this measure, this length, so it would be Y times 3, so 3Y, and 6 times 4 is 24. So 3Y is equal to 24. So it means Y is going to be 8. So it's 8 centimeters. So this is 8 centimeters. Okay, for the last question, what's the measure of angle H? Where's angle H? This angle. Okay, these are similar figures. If this is 70 degrees, then point B corresponds to point F. So it means this is also 70 degrees. Okay, to find this angle, quadrilaterals total angle measures 360 degrees minus the sum of 170 and 85. So minus the sum of 170 and 85. So if we're going to add these three numbers, it's going to be equal to 255. So minus, we have to subtract 255 from 360 degrees. It's going to be 105. So this is now 105 degrees. So measure of angle H is 105 degrees.